Welcome. So in this part of the lesson, we're going to answer this question before us, which says that we need to find the values of m for which the equation this has real solutions. Okay, first off, we know that this is a discriminant question because it's talking about find the values of m for which this has real solutions. So in other words, when it says real solutions, it's saying it has x intercepts. I can't spell intercepts. X intercepts. There we go. So it has x intercepts. Now, in order for it to have x intercepts, you need to think, well, what is my discriminant therefore going to be equal to? Don't write this down for a second, but you know that if it has one x intercept, it's going to be equal to 0. So that would be true. Or if it has multiple x intercepts, it's going to be greater than 0. So if it has some amount of x intercepts, what that means is that it's going to be greater than or equal to 0. So that's what we can say here. It's definitely not less than 0, because that means there are no x intercepts. It's going to be greater than or equal to 0. So there we go. We've just figured out that my discriminant has to be greater than or equal to 0. Then after this, it becomes a bit routine. We're going to figure out what a, b, and c are going to be equal to. A will be 3 because it's just the coefficient of x squared in this case. B will be the coefficient of x. In this case, that's going to be negative 2m. So it's whatever is in front of x. So in this case, what's in front of x is negative 2m. And then finally, the c is just the constant at the end here. So it's just going to be 3. We're now going to sub that into our discriminant. So it's going to be b squared, so negative 2m squared, minus 4. Then in my a spot, I'll put a 3, and then in my c spot, I'll also put a 3, because a and c are both 3. Then we keep on going here. This is going to be 4m squared minus, now 4 3s are 12, times 3 is 36. There it is right there. All right, the next thing we can add to this is what my discriminant is equal to, and we know that my discriminant has to be greater than or equal to 0, right? So that means, because I know that my discriminant has to be greater than or equal to 0, 4m squared minus 36 has to be greater than or equal to 0. What is this now? It's a quadratic because my m is squared, right? So I've got a quadratic and it's an inequality. I've got a quadratic inequality. How do I solve a quadratic inequality? You must sketch a quadratic inequality. As we saw in our previous lesson, whenever you've got a quadratic inequality, you must sketch it. So we now need to sketch this. We must sketch this. So that means I need to sketch, and I'll do this in red, I need to sketch 4m squared minus 36, the discriminant. I need to sketch that out. To do this, I need to find my m intercepts, because it's in terms of m, it's not in terms of x, so we're not finding our x intercepts, we're finding the m intercepts of what we're dealing with here. To do that, I'm going to have to factorize this. How am I going to factorize this? Well, hopefully you can recognize that this is a difference of perfect squares. So it's just going to be 2m minus 6, 2m plus 6. Whenever you're trying to solve for intercepts, you have to set it equal to 0. Because now you can use your null factor theorem to say, well, 2m minus 6 is going to be equal to 0, and 2m plus 6 is going to be equal to 0. That means m is going to be equal to 3 in this case, or over here is going to be equal to negative 3. So 3 or negative 3, those are your m intercepts. If we now give this thing a sketch, let's see what we're dealing with. So I'm going to draw this. I'm going to draw this. Now, it's a bit confusing, but remember, this is the discriminant is equal to 4m squared minus 36. So my y-axis is the discriminant. So the vertical axis is the discriminant axis, and this is my m-axis. I know that I have intercepts at negative 3 over here and 3 over there. I then can give this thing a sketch. So it's going to look like this. Like that. Not the prettiest graph in the world, but that's okay. We're not being judged on how pretty our graph is. Now, we want to figure out when my discriminant is greater than or equal to 0. So that means I'm including all of this and all of this. That's what I'm including there. And you have to make sure that you're including your m-intercepts, because that's when it's equal to 0. So that means my final answer here, after all is said and done, is m is going to be less than or equal to -3, or my m is going to be greater than or equal to 3. That is my final answer. So in order for that equation that we saw up above to have real solutions, my m values are either going to have to be less than or equal to -3 or greater than or equal to 3. So in order for this to have real solutions, my m value has to be less than or equal to -3, or m has to be greater than or equal to 3. If we're kind of still struggling to understand what this exactly means, what we can do here is we can use Desmos to help us demonstrate what's going on here. So let me bring up Desmos, and what I'm going to do is I'm going to sketch this. So this thing right here, this formula right here, this equation, I'm going to sketch it. Here it is. Let's move this over here. There it is right there. So 3x squared minus 2mx plus 3. That's what we're dealing with. And remember, the question said, find the values of m for which this has real solutions. And according to our answer was, well, if it's greater than 3, so let's take out this m here. It's like a scroller. So I'm changing the value of m. I'm going to make my m greater than 3. So for instance here, let's just make it exactly 4. When it's 4, do you see how I have 2 x-intercepts? And for any value greater than m, hopefully you can see there that I'm always going to end up with 2 x-intercepts. What if I bring it up slowly, slowly, slowly? Do you see what happens when m is equal to 3? When m is equal to 3, I have 1 x-intercept. And that's exactly what we saw over here. So if we look at our answer again, when m is greater than or equal to 3, this thing is going to have real solutions. So even when it's equal to it, it's going to have 1 solution there, just as we see on this. If we then keep bringing it over, over here, when it is, wait for it, -3, it also has 1 x-intercept. And then when it's less than -3, do you see how you again have more than 1 x-intercept? You have 2 x-intercepts when it's greater than when it's less than -3. So that's how this thing is working. Hopefully you can see what's going on there. And this makes sense. Having a little visual like this is very useful. Okay, hopefully that makes sense. There's 3. There's -3. That's when it has 1 solution. If it's less than -3, it has 2. When it's greater than 3, it has 2. When it's in between either one of those, it has none. Okay, hopefully that makes sense. And I'll see you in the next part.